Okay, so good afternoon, everyone. Welcome to Physics 71. The topic for today is momentum conservation and collision. So last time we started our discussion of linear momentum. We defined what linear momentum is, and it turns out that Newton's second law is originally written in terms of momentum rather than acceleration. And then after that, we defined impulse, and we've shown that the impulse is just the change in the momentum of an object. We also or of a system. So we also solved problems involving the relationship between the momentum and the impulse of the system. We have calculated some numbers, like for example, the average force and the change in momentum of the system, yung mga ganong numbers, ganong values. We calculated these numbers here. Okay, so now let's go to momentum conservation, the main point of this lecture, of this discussion, why we are discussing momentum, because there are some problems that we need to solve using conservation of momentum. Okay, here's an outline of this discussion. So first, we discuss conservation of momentum. And then second, we discuss collisions in 1D. What I did, by the way, is to rearrange the lectures 18 and 19. Some of the topics that I will be presenting here in lecture 18 are actually in the annotated lecture slides are in lecture 19. But I believe it's much more convenient, or it's much more systematic, if we discuss first 1D collisions and then extend that definition to 2D. And then there's a supplementary discussion that I'll be giving at the end of the lecture, if time permits. Hindi nyo kailangan panoorin to. But this is really important because it shows you how do we have this important proof on elastic collisions. While we can use the equations that we have, just like as if it's God-given, pwedeng God-given yan, but there's a relationship between the kinetic energies and the relative velocity relations for an elastic collision. So yan yung pag-uusapan natin as we go along. But this again, let's see if time permits so I can discuss this, because we have a lot of problems to right now. So tignan natin kung ma-discuss natin. But I hope I can discuss it either live or through a recording. Okay, if hindi ko naman ma-discuss, i-record ko rin naman yan. I-upload ko pa rin siya. So you may watch it as well. Okay, so here are the ones that we will be discussing for this session. And then for tomorrow, we will also discuss 2D collisions. Do natin i-extend yung definitions natin. Okay? Again, for those who are watching on YouTube, some parts of what I'll be discussing as lecture 18 is in lecture 19 of the annotated lecture slides. For example, elastic collisions are in lecture 19. Okay, huwag kayong malilito. Binago ko lang ng konti yung sequence. Okay, sige. Now, here are some objectives of the discussion. At the end of this lecture, you should be able to attain the following or achieve the following. You enumerate the conditions for conservation of linear momentum. So how do we say that momentum is conserved? What is the main condition for which for us to say that momentum is indeed conserved? And then second, we apply conservation of momentum to physical systems, especially to collision problems. Of course, there's a more formal definition of what a collision is. Yun yung basis natin kung paano natin masasabing, okay, conserve ang linear momentum dyan. Or I should say, approximately conserved ang linear momentum dyan. Okay, and then we determine whether a collision is elastic or inelastic. There are again certain conditions for which we can say that the collision is either elastic or inelastic. And we predict the motion of constituent particles for different types of collisions. What will happen if the collision is elastic? What will happen if the collision is partially inelastic? And what will happen if the collision is totally or perfectly inelastic? So, pag-uusapan natin yan. And then finally, we utilize the concept of mechanical energy and momentum conservation in solving collision problems, because sometimes you need both of them. You need conservation of momentum, or you need conservation of mechanical energy to determine some physical quantities, like for example, velocities and heights, for example, if you want to determine or to predict these physical quantities, the measurements of these physical quantities. Okay, without further ado, let's go to our topic for today. So, recall our momentum and impulse. Nag-recall na ako sa start ng discussion na to. Again, the linear momentum P is just a vector that's parallel to the velocity of an object. It's the mass times the velocity of an object. So, and then the impulse is just the effect of the average force over imparted on a system at a certain time interval delta t. And it turns out that when we derived our expressions yesterday, dun sa mga hindi nanood ng video lectures yesterday, please watch it yesterday, these lectures, kasi baka hindi nyo maintindihan yung pinagsasabi ko dito when we go to conservation of momentum. Okay. Now, from the video lectures yesterday, we have shown that the impulse is just the change in the momentum of the system. So J equals P2 minus P1. Okay. So, okay, questions for so far dito. May tanong ba dito? May mga tanong ba?
Sir.
Okay. I hope this is clear. Sige. Now, okay, let's consider an isolated system. Sige. For the meantime, let's consider an isolated system. Or for example, halimbawa may dalawang astronauts. Dalawang astronauts na nasa space. So it means that the gravitational force acting on other bodies is much smaller, that it is negligible compared to the interaction of these two humans here, of these two astronauts here. So basically, you have astronauts that are interacting. Siyempre, pwedeng magbanggaan yung dalawang yan, di ba? Or of course, there is a mutual gravitational attraction on these two. We will not discuss gravitation until the end of this course. Pag-uusapan lang natin sa mga bandang dulo-dulo. But for the meantime, let's say that they are interacting with each other. May interaction sa kanilang dalawa. So, kung may interaction sa kanilang dalawa, ano mangyayari? So, if we treat these two as a single system, then the force exerted by A on B and the force exerted by astronaut B on astronaut A, they are internal in nature. Diba? Internal yan kasi trinit mo yung system na itong buong to, yung buong sistema mo. So, itong buong to, system mo yan. So, it means that all the interactions between A and B are internal. Okay? Internal yan. Hindi siya external. Hence, if there are no external forces acting on it, in that case, the force exerted by A on B, by Newton's third law, is equal in magnitude and opposite in direction. So, as that of the force exerted by B on A. Diba? So, yung mga force vectors na yan, equal in magnitude, opposite in direction by Newton's third law. So, wala kang masasabi dyan, no? Ang masasabi mo lang, okay, edi since this is the entire system, this two-body system here is the entire system, there is no external force acting on the system. Diba? Wala namang malaking body dyan sa labas na kung saan mag-a-act yung magkakaroon ng additional force na mag-exert dyan. So the point here is there's no net external force acting on the system. And hence, the impulse also, which is the change in momentum, have equal magnitude in opposite direction. Kasi nga, your forces are equal in magnitude in opposite direction. And the contact time, more or less, is also the same. Therefore, the impulse is also the same. Diba? Equal, same magnitude, opposite in directions. Kasi yung impulse imparted by A and B is in this direction, I should say, this direction. The impulse imparted by B and A is on the other direction. So, parehas lang yung magiging impulse ng dalawang yan when it comes to magnitude and they're opposite in directions. Therefore, there is no change in the momentum of the system because the impulse vanishes. Diba? J becomes 0 and therefore delta P is equal to 0 and therefore the initial and the final momenta of the system are the same and hence momentum is conserved. Okay? So ganun siya. Ngayon, again, I want to emphasize here that there are no net external forces acting on the system because all the forces that are exerted on A and B are internal. Internal, nasa loob siya ng system. Okay? Questions? May tanong? Questions? Wala?
Sir.
None. Okay. Now, so there's this thing called conservation of momentum because we know that if there's no net external force acting on the system, then we could say that the momentum is conserved. Bakit? So if you have two isolated interacting objects here, the total momentum is just P total. For example, Young and Friedman has written it as capital P. I don't like that notation, to be honest. That's why I edited it to P total. P total is just the sum of the momenta of A and B. So PA and PB. So from Newton's second law, the net external force acting on the system changes the system's momentum. Now, since there are no net external forces acting on the system, then F external vanishes, this becomes 0, and therefore this is equal to 0. What can we say about the momentum? The derivative, if a function has a 0 time derivative, what can we say about that function? If d dt of something equals 0, what can we say about this something here? Ano masasabi natin from your Math 21?
Constant.
Constant lang yan, di ba? It's constant in time. In strictly speaking, it's constant in time. Therefore, the momentum here is constant in time, and therefore, it should be conserved. dp dt is equal to 0, and therefore, the total momentum is constant, and hence, the initial and some final momentum, if we measure it at some initial time and at some final time, that total momentum should be the same. That is, the total momentum at some initial state is equal to the total momentum at some final state. Okay? Clear ba yon? So that's basically what conservation of momentum is. Because there is no net external force acting on the system, then the momentum, the total momentum of that system is constant and it is conserved. Okay? Questions? May tanong? Wala?
None, sir.
None. Okay. Thank you. So the conservation of momentum statement is if the net sum of all the external forces on a system is zero, then the total momentum of the wow, what is this phrase? Sorry for that typo. The total momentum of the system is conserved. That is P total initial is P total final. So some important notes here. The P total the total here is again the net sum of all the momenta initially and initial and final. So remember, we are now talking of systems. We are not just talking of single particles. Kasi kung isang particle lang yan, wala naman yung paki-interactan, di ba? Kanino mag-interact? Yan, isolated particle lang yan, di ba? Parang, kanino siya makikipag, halimbawa, tao. Kung isang tao lang yan, kanino siya makikipag-usap sa sarili niya, di ba? O, ginagawa ko yun minsan. Madalas pala. Anyway, so the point here is it should be a system of 2 or more particles because you are now treating them as interacting bodies. Nag-interact yung dalawang, yung mga particles na yan. And hence, you need to measure the total momentum of all these particles, not just of one of them. Hindi necessarily na conserve ang momentum ng isang particle sa kanila. Ang kailangan lang ay conserve lahat ng sum ng mga momenta ng bawat particles. Okay? That's clear, diba? Clear naman yon. We're talking of the total momentum initially and at the initial state and at the final state. Okay? Questions? So, now, remember, again, momentum is a vector quantity. You need to add these vectors, these quantities vectorially. You need to compare them by components. Mali yung ginagawa dito na pinag-add lang yung magnitudes ng mga momenta. Mali yun. Because again, momentum is a vector quantity and this equation here is a vectorial equation and you need to decompose it by components para malaman mo yung total momenta. Okay? So for now, for this lecture, we will only consider one-dimensional collisions. Then tomorrow or next time, we will be discussing 2D collisions. So doon natin pag-uusapan how do we extend our calculations for now in 2 dimensions. So, okay, doon na magiging masaya yung mga problems. So far, pero masaya pa rin naman yung mga problems ngayon. Okay? Questions? So, again, another thing that I want to emphasize, I almost forgot, is that we are talking of the net external forces. Net external. So this means that this should be 0 dp dt, di ba? This is 0. We are talking of the net sum of all external forces. Hindi kailangan walang force. Ang kailangan lang, namamatay lahat ng forces. That is, lahat ng net external forces on the system, they cancel each other. Okay? So pwedeng may force na nag-act dun sa isang system, but these forces should cancel out. Therefore, the effect of them should be 0. Okay? Questions? Gets ba? Gets to? I hope this is clear. Okay, thank you. Now, so again, the components are Px, Py, and Pz. So we can also, I think discuss ko na to kahapon, we can also relate the kinetic energy and the momentum of the system. It turns out that if the kinetic energy is, of course, 1 of mv squared, you already know that, we can express this K in terms of momentum. So the momentum is basically P is mv, and therefore, I can write this v vector here. So V vector here is equal to P vector over M, and then I can substitute it to K. One important thing that I want to emphasize is that V dotted with V is equal to magnitude of V squared. Bakit? Bakit? Kasi naalala nyo, this is simply magnitude of V cosine of the angle between them. But what is the angle between two equal vectors? Ano lang yan? Halimbawa, meron akong V dito. Meron akong V dito. Ano ang angle between dyan? Diba 0, of course. Obviously, this is 0, therefore this is equal to 1, and then this is magnitude of V1 V squared. Yun kasi kailangan mong gamitin dito. So, V squared here is the magnitude of the velocity quantity squared, which is equal to the magnitude of the momentum squared over m squared. And hence, when you substitute that to our expression of kinetic energy, we get K equals 1 of m quantity P dot P over m squared, and therefore K is P squared over 2m. Okay? This is important for those who will be taking Physics 73, makikilala nyo ulit itong P squared over 2m. Doon sa mga mag-take ng 73 especially. Okay? Some of you are from triple E, right? May 73 kayo, guys. Actually, that's the Chila 7x. So, for me, siya pinakamadali. Okay, anyway, you'll see this is important. This is an important equation when we go to quantum mechanics, for example. May reason kung bakit. But I won't spoil it. Bigyan na natin sa 73 instructors niyan. Okay? Sige. Now, so